All right, today we're going to tackle Java thread control, but let's forget the dry textbook stuff for a bit. Instead, we're going to imagine we're running a super busy restaurant. You'll see, managing cooks in a chaotic kitchen is actually the perfect way to understand how Java manages its threads.
And that's really the core idea here. In Java, just like in a kitchen, you just can't have every single task running at full speed all the time. I mean, it would be total chaos, right? So effective management is all about coordination. It's about knowing when a task should pause, when it needs to wait for another one, or when it needs to stop altogether.
So let's kick things off with the most common situation you'll run into, just pausing the work. In any kitchen, there are going to be natural lulls. Even the best cook needs a break, and, well, threads are exactly the same. So picture this. The big dinner rush is over, and one of our cooks decides, okay, I'm taking my scheduled 10-minute tea break. Now, he's not getting fired, he's not quitting, he's just hitting the pause button for a very specific amount of time. In the world of Java, this is the Thread.sleep method. It's really straightforward. You're just telling a thread to go into what's called a timed waiting state for an exact number of milliseconds. It's a guaranteed pause. And this comparison lines up just perfectly. The cook's fixed break, that's the thread pausing. The cook coming back to work, that's the thread becoming runnable again. But the really interesting part is that last point. If there's a kitchen emergency, the manager can call that cook back early. And that's why sleep can be interrupted, which throws an interrupted exception. Okay, so here is your key interview takeaway. Sleeping pauses a thread, but, and this is crucial, it's kind of selfish. It holds on to any resources or locks it was using. Think of it like a cook going on break but taking the only spatula with him. If other threads or other cooks are waiting for that same resource, they're just stuck, and that could jam up the whole system.
Okay, let's switch gears to a different situation. This isn't a scheduled break. This is one cook seeing his coworker is totally swamped and saying, hey man, you go first, use the grill. It's not a command, it's just a polite suggestion, a little bit of teamwork.
This is exactly what Thread.yield is. And the key word here, the one you absolutely have to remember, is hint. The running thread is basically telling the Java scheduler, hey, I'm willing to step aside if someone else needs the CPU more than I do right now. And this is probably the biggest misunderstanding about yielding. It's just advice. The scheduler, our kitchen manager, is totally free to ignore it. Maybe no other cook is ready to work, or maybe the current cook's job is just too important. So there is absolutely no guarantee that another thread will run. Now, let's build on that. Pausing is one thing, but what about when things really need to be coordinated? I'm talking about tasks in the kitchen that can only happen after another one is completely finished. This is all about managing dependencies. I want you to think about the final step for any order. The person at the packing station is ready to go, but they're completely blocked. They literally cannot do their job until that cook finishes grilling the burger. They simply have to wait. This maps one-to-one with the join method. When the packer's thread calls cook.thread.join, it literally stops everything and waits until the cook's thread is done. It's the main way you enforce a sequence of events and make sure things happen in the right order. So here's your interview one-liner. If you ever need to explain how one thread waits for another to finish its job, join is your answer. It's the classic tool for managing thread dependencies. Simple as that. So far, we've really only been talking about the main cooks, right? But every great restaurant has a whole background crew, those unseen helpers who are just keeping things running smoothly behind the scenes. Now, what's really cool here is this clear distinction. You have your main staff, the cooks, the packers. In Java, these are your user threads. They do the main work, and the restaurant stays open as long as they're on the clock. But then you have the background crew, the cleaners, the maintenance guys. These are Daemon Threads. Their only job is to support the main staff. And here's the key. When the last cook punches out and goes home, the cleaners pack up and leave too. The restaurant just closes. So the most crucial point to remember is that the application, our restaurant, does not wait around for Daemon Threads. The second the very last user thread finishes its work, the whole program shuts down, and any Daemon Threads are just terminated automatically. A perfect real-world example of this is Java's garbage collector. It's a classic Daemon thread. All right, time for a little bit of drama. Everything's running along just fine, but then, bam, an emergency strikes. The manager has to shut things down, and fast, but they have to do it safely. Just imagine there's a gas leak. The manager is yelling for everyone to stop what they're doing. But a cook can't just drop a pan full of flaming oil and run for the door. That would cause a fire.
No, they need to turn off the stove, put the pan somewhere safe, and then exit. It absolutely has to be a graceful shutdown. And this is pretty much exactly how Java handles it. The manager calling Thread.interrupt doesn't just kill the thread on the spot. All it does is raise a little interruption flag on that thread. Then it's up to the cook, the thread's own code, to periodically check, hey, has my flag been raised? And when it sees that the flag is up, it knows, okay, time for me to clean up my station and shut down safely.
This is probably the most important concept to get about interruption. It's a cooperative model. The manager asks the cook to stop. They don't physically drag them out of the kitchen. The thread itself is always in control of its own shutdown process.
Okay, the shift is over. Time for a quick manager's review. Let's go over the big rules we learned, and more importantly, the common mistakes we need to avoid.
So listen up, because these are the big ones. First, never, ever use the old deprecated stop method. It's like tackling a cook while they're cooking. It's dangerous and totally unpredictable. Second, if your thread doesn't check its interrupt flag, it's like a cook wearing headphones who completely ignores the fire alarm. Third, always remember yielding is just a polite suggestion, not a command. And finally, please don't use sleeping to try and coordinate threads. That's what joining is for.
And there you have it. You're basically a restaurant manager now. You know how to handle breaks with sleep, how to politely step aside with yield, how to manage dependencies with join, run background tasks with daemon threads, and even handle emergencies with interrupt. You've got all the tools you need. But all this leaves us with one last really crucial question. We figured out how to manage their time and their dependencies. But what happens when two cooks need the exact same shared resource, like a single frying pan, at the exact same time? Well, that's a whole other problem called synchronization, and we'll be tackling that one in our next explainer.